Hi there, welcome back to this channel. In this video, I'm going to be proving the following identities to you, that the sine of A plus B is equal to sine A cos B plus cos A sin B, and that cosine of A plus B is cos A cos B minus sine A sin B. I'm going to be proving that in two ways. So I'm going to use the one I like the most, the method of proving that I like the most. This one uses a triangle that looks like this. A triangle that looks like this, such that this part is about 90 degrees. It is about 90 degrees to this point, 90 degrees. Then another triangle, we are going to draw another triangle from that same point, which is also at 90 degrees. Also at 90 degrees. There's a perpendicular to this point. Then we'll label the points. We have A, B, C. Now we can make another right angle triangle out of this, like this here. Then this one we can draw it straight down this point. Then another right angle triangle out of this place. So this is point C, point D. A, B, C, D, E, F. Exactly. I want you to see the way I'm constructing it. Exactly. All right. This said, we will now label our angles. The angle here will be alpha. The angle here, let it be beta. Don't confuse it for A and B. Okay. We could use angle theta, alpha and theta. Let's use alpha and theta. All right. So if we want to find sine of alpha plus theta now, we know that it's going to end up being sine alpha cos theta plus cos alpha sine theta. All right, but the way I'm going to be proving this is like this. Now watch. We need this. We need to take the sine of this entire angle. The sine of alpha plus theta is going to be the sine of this place plus this place. So if that is the case, then the triangle we are looking at is this big triangle here. That has A here, B here, and E here. Then this place, our angle here is theta plus alpha. So this place will be our opposite. So the sine of this will be opposite, which is B. So the sine of this is sine of alpha plus theta is actually opposite, which is B, line B, over hypotenuse. The hypotenuse is AB. Okay, so that's line AB. All right. Now, we know that line BE can be divided into two. There is BD and DE, isn't it? So this becomes BD, line BD, plus line DE. That's what gives us BE, right? Over line AB. Does this make sense? Then from here also, we know that line DE is going to be the same length as line CF. Line DE will have the same length as line CF. So we can rewrite this as line BD plus DE is the same as CF, so we replace that as CF over AB, line AB. All right. Now we will distribute this denominator for both of them, and it becomes, I'm going to bring that down here, it becomes line BD over line AB plus CF over line AB. Is that clear? Now, this done, let's identify the parts. BD over line AB, where is it? This is BD, and where is AB? AB is here. Now notice that line BD and line AB are not in the same triangle, right? But as well here, CF and AB are not in the same triangle. But there is a part that they have in common. So that part that they have in common is the part that we're going to use to find solution to this thing. So which part does BD and AB have in common? This is BD and this is AB. So they both have this part, this side in common. This side is part of this small triangle, and this part here is part of this larger triangle. Exactly. So it means that what we now do, the trick we are going to do is to multiply this common part. We are going to make it a fraction, which will be 1, and use it to multiply this fraction here, because these two parts have it in common. So it will be line BD multiplied by this side, which is BC, over BC, this one over line AB. I hope you understand what I did. This is 1 that I used to multiply it, so nothing has changed. Exactly. It's just a manipulation I did there. Then plus line CF. CF is this side. So this side and AB, where do they have in common? This side is part of this triangle, and this side is part of this triangle. So they have this side in common, which is AC. So we multiply CF and AB, we multiply it by AC, which is this side, over AC. Does that make sense? All right. So from here, we can now do another manipulation. All right. So from here, it becomes, look at the way I'm going to do it. It will become, I'll bring this up. It becomes line BD over, I will interchange this. That will become BC multiplied by BC over AB. Keep in mind I've not changed anything. BC can still take care of BC. Then plus CF multiplied by AC, line AC over, here will be over AC. I'm going to switch, I'm going to make these denominators switch places. Keep in mind also I've not changed anything, as AC can take care of AC. But there's something that has changed here. I'm going to show you in a jiffy. Alright, so another thing we'll now do is find some of these angles out first. You know this place is theta. So using alternate angles, this place will also be what? Theta. Does that make sense? Now if this place is theta, and this place is 90 degrees, then this place must be 90 minus theta. Does that make sense? If this is 90 minus theta, and this is 90 degrees, then this place must be theta. Exactly. Such that theta plus 90 minus theta plus 90 will give you 180. I hope you understand. If these two places together make 90, and this small place is theta, and this place is 90, it means these two places must also make 90. Do you understand? So that means that this place must be equal to this place, which is also equal to this place. Exactly. All right. Now, what is now BD over BC? Where is BD? This is BD, and what is BC? This is this place. Now, relative to this triangle and this angle, what is BD? BD is adjacent over, what is BC? Hypotenuse. So that is cosine of this angle theta. Cosine of theta will be adjacent over hypotenuse. So that hypotenuse here is this place, is BC, so that's why it is cos theta. Then multiplied by BC, which is this side, over AB. Now, of this bigger triangle here, BC is opposite of angle alpha. So it will be opposite over adjacent. Exactly. So that is sine rather. Opposite over hypotenuse rather. Opposite over hypotenuse is sine of alpha rather. Of alpha. Then plus CF. CF is this place over AC. So CF is opposite of angle theta. CF is opposite of angle theta. So that will be sine theta. Sine theta multiplied by what is AC over AB? AC is here. AC over AB. Where is AB? AB is here. So relative to this angle alpha, AC is adjacent. So adjacent of hypotenuse again, that's cosine, right? Cosine alpha. You remember I'm using SOHCAHTOA, right? SOHCAHTOA. So opposite of hypotenuse. That's what we have here. Exactly. All right. Then we have proven that sine of alpha plus theta is equal to, I like to write the sine first, so it will be sine alpha cos theta plus cos alpha sine theta. Is it clear? So that's the proof there. I'm going to prove it in another way, but before I prove it in that second way, let me show you that of cosine. Let me show you that of cosine. Cos alpha plus theta. Now, how do you prove this? How do you prove this? Cos alpha plus theta. Now, what is cos alpha? Cos alpha there, cos alpha plus theta there will be the big triangle again, that big triangle, that will be adjacent AE. So cos alpha plus theta, this whole thing is equal to the adjacent AE over the hypotenuse AB. Is that clear? Now, this side AE can be written as, it can be written as line AF minus EF, because look at it, this is AE. So if you subtract AF, if you subtract EF from AF, you get AE. Exactly. So over line AB. Okay, so we're going to do the same manipulation, the same way we did for AE. So you can complete it yourself, and you can pause the video and complete it yourself. So EF here is this side. Right? We know that this side, if you bring it up, it corresponds to DC here, right? So it means that we have AF minus DC over AB. Is this clear? Now, we can now distribute the denominator such that this becomes AF over AB minus DC over AB. Alright? So from here, let's identify the parts. AF is this long base here, and AB is this side. Notice they are in different triangles again. So we'll do the same thing. Look for a common part, a common side that connects both triangles. Look at this side. This guy is on this triangle, and this side is on this triangle. So which side connects them? It is AC. So we use AC to multiply up and down. So it becomes AF over AB times AC over AC. Keep in mind I have not changed anything. I have only multiplied with 1. Anything times 1 will give you the same thing, right? Minus, what about DC? DC is this side here. Okay? So, and AB is this side. DC is here, AB is here. AB is in this big triangle, this is in this triangle, this small triangle here. Now, which part do they have in common? They have this side in common, that's BC. So we use that part that they have in common to multiply up and down. So it becomes DC over AB multiplied by BC over BC. Is that clear? So if that be the case, we are going to rearrange another manipulation we did there, so that it becomes AF times AC all over AC times AB. AC times AB. Okay, let's just put the times here. I just switched change the places, exactly, the place of these guys. So, and you get the same answer, right? Because multiplication is commutative. So, A times B times AC is the same as AC times AB. And keep in mind, this can still cancel out. So, we have not changed anything. That's what I'm trying to show you. So, DC times BC over here to be over BC, now here over AB. So with this that we have changed, then something has happened. AC and AF over AC is AF over AC. So what is AF? Is the adjacent of this angle theta. Is the adjacent of this angle theta. You know, the triangle is like this. This is AF, this is AC. Okay? So relative to angle theta, this will be adjacent over hypotenuse. So what's adjacent over hypotenuse? As cos. So here we have cos of theta multiplied by AC over AB. What is AC? Here. Over AB. Here. So that will also be adjacent over hypotenuse for alpha this time. So that will be cosine of alpha minus DC over BC. DC is here and BC is here. So relative to this angle here, angle theta, this thing is opposite. DC is opposite, this is hypotenuse. Opposite hypotenuse. So that will be sine. Opposite over hypotenuse, that's sine. So sine of angle theta this time multiplied by BC over AB. BC is this side, AB is this side. So it will be opposite for alpha now. Opposite over hypotenuse. Is that clear? That will be sine again, but this time alpha. So we've proven that cos alpha plus theta is equal to cos theta cos alpha minus sine theta sine alpha. Exactly. So you should you can try it on your own. Now before I prove the other identity that sum to product showed, I want you to see something else. I'm going to be using another method to prove it. Okay, so I'm still going to use the same triangle, but I'll change something this time. So what we still have is this guy, this system like this, but this time we're going to make our hypotenuse here, this hypotenuse here, we'll make it have a value of 1 unit. So if it is 1 unit, then the entire thing will begin to our manipulations will change in a way. Now if we want to take, if we call this side, let's call this side X, let's call this side Y. Okay, so if you are looking for X, for example, X will be relative to this angle phi, it will be sine alpha. You know that sine alpha will give us what? This guy, which is X, over this side, which is 1. Meaning that if we cross multiply, X will be equal to what? Sine alpha. So this side is actually sine alpha. Do you agree with that? What about this side? We call it Y. Now you know that if you are looking for this side, you basically can say cosine relative to this alpha, this side is adjacent. So cosine of alpha is going to be equal to adjacent Y over hypotenuse 1. So that Y becomes what? Cosine of alpha. Meaning that this side becomes what? Cos alpha. Okay? So means we have a triangle that looks like this, where the hypotenuse is 1, the opposite is sine alpha, and the adjacent is cos alpha. Okay, so from here we can also get something for this guy. Using this side here, you know that if you want to take the sine of, you want to get this side, let's get this side. Let's call this side, let's call it Z, for example. That will be adjacent. That will be cosine of theta will be equal to adjacent, which is Z, over hypotenuse, which is sine alpha. Meaning that Z is equal to what? Cos phi sine alpha. Let me show you again. Cos theta rather sine alpha. Cos theta, because it is cos theta we're trying to take to get Z, adjacent by hypotenuse. Exactly. So that is the value of Z, meaning that this place, this small part here has become what? Cos theta sine alpha. Okay, don't get confused. Now for the bigger side here too, for this bigger guy here, If we want to look for this side, if we need this side, we can use, we already have hypotenuse here, so we are looking for here relative to this angle theta, this side is going to be opposite. So that will be sine. So let's call this place, let's call it M. So M will be equal to find M, it will be sine theta being equal to opposite M over cos alpha, meaning that M will be equal to what? Sine theta cos alpha. Makes sense? So this place is no longer M, we have gotten it to be sine theta cos alpha. Remember that this length is the same as this length, right? So we can bring this guy here to be sine theta cos alpha. Exactly. If that be the case, our big triangle will now look like this. There is this side, we have A here, we have B here, and we have E here. There is this side which is 1 unit, and there is this side which is sine theta cos alpha plus the entire length is this place plus this place. So the other side is cos theta sine alpha. Is that clear? Well, let me write it well so let's just put in bracket like this side is sine theta cos alpha plus cos theta sine alpha. So what will be the angle here? The angle here is this entire angle, which is alpha plus theta. So that is alpha theta plus alpha. Alright, if that be the case, then to find the sine of theta plus alpha, then theta plus alpha will become opposite over hypotenuse, right? Sine of this will become opposite over hypotenuse, which is this side. Opposite will be sine theta cos alpha plus cos theta sine alpha. So over 1, and that remains the same. So you see, it is exactly the same. It is exactly the same. So that's how to prove it. One of what I'll ask you to do is first try to prove using this unit hypotenuse. Prove that cos alpha plus theta is that, and put your answer in the comment section below. Now the next thing I'm going to prove is the sum to product rule. The sum to product rule. Let me pause the video. So to prove the sum to product rule, here's how we're going to go about it. We'll start with those identities we generated with our proof. We have that sine theta. Let's use A plus B this time because I'm not using a triangle, so the letters should not confuse us now. So let's use sine A plus B. We said will give us what? The sine A cos B plus the cosine of A sine B. And that the sine of A minus B will give us just sine A cos B minus this time sine cos A sine B. Alright, so what we'll try to do is, want to do sum to product now. Sum to product. Now, if you add equation 1 and equation 2, this is equation 1, this is equation 2. Equation 1 plus equation 2 will give us, this is positive, this is negative, and they are the same, so they will cancel out. Is that clear? So what you will have here, down here you will have sine A plus B altogether plus sine A minus B. Is that clear? Will be equal to here sine A cos B plus sine A cos B. Is that clear? So let's make A plus B. Let's make it something simpler. Okay. Let's make it something like alpha, and let's make A minus B. Let it give us beta, for example. So if this be the case, then this place becomes sine alpha plus sine beta. So this is sum. we want it to turn to product. So it will become sin A cos B plus sin A cos B. That's 2 sin A cos B. Does that make sense? Why? Because sin A cos B appears twice. So we are going to just put 2 here. All right. If that's the case, then we have to get we have to write this equation in terms of alpha and beta, not A and B. So what we'll try to do is generate a term for A and B in terms of alpha and beta. So the first thing we'll do here is let's solve this simultaneously. We'll use the elimination method. This guy goes. We add equation 1 to 2. This plus this gives us 2A is equal to alpha plus beta. So meaning that A will be equal to divide both sides by 2. A will be equal to alpha plus beta over 2. Then in the second case, we write A plus B equal to alpha and A minus B equal to beta. Then if you subtract equation 1 from 2, A minus, if you subtract, this becomes 0, and it becomes B minus B, that's 2B plus B will be equal to A alpha minus beta, that will be alpha minus beta. Divide both sides by 2. Beta becomes alpha minus beta over 2. So from here, we have generated a term for A and B in terms of alpha and beta. So sin alpha plus sin beta becomes 2 sin, what is our A? A is alpha plus beta over 2. That will be alpha plus beta over 2. Then cos B, what is B? Alpha minus beta over 2. Alright, so this brings us to the end of the video. So if you have, for example, sin 15 plus sin 45, we can use these to evaluate it. Is that clear? In this case, it will become 2 sin, what is alpha? 15 plus beta is 45 over 2. Then cosine, what is the alpha again? 15, this time minus beta. Okay. I mean, you can change this thing so that it becomes positive before negative. Okay. So if you make this guy negative, you make this guy 45. Let's make this guy 45 and this guy 15. I mean, it doesn't change our answer because cosine of a value of a negative this will give you a positive, but the sign of negative gives us negative answer still. All right, so here it will be 45 plus 15, and here 45 minus 15 over 2. So here we're going to have 2 sine, here will be 60 over 2, cosine of 30 over 2. In which case we'll have 2 sine 30 cos 15. Is that clear? So cosine of 15 will be, I can't remember, you have to do this again. You have to do, that's another identity to even find this, okay? Cosine of 15. For example, you know that, we know the what's it called now? The special angles. Sine of 30, cos 30. Cos 30, for example, is root 3 over 2. But we do know that cos 30, for example, watch. Cos 30 is the same as, cos 15 rather, will be the same as cos 30 over 2. So what we'll try to do is let's generate an identity for the cosine of an angle over 2. Is that clear? Alright. So if that is the case, then you know that this can be written as cosine of the angle over 4 plus another angle over 4. I don't know if you understand this. Theta over 4 plus theta over 4. 15 will be 30 over 2. Okay? So if we need an identity for theta over 2, not, I'm trying to show you we wanted to find for half, okay? But now we want to find for example, We want to find for 15 now, so we'll take 30 over 2, right? So let's generate an identity for theta over 2 plus theta over 2. That's what gives us 30, right? So that will become cos theta over 2 plus, it doesn't really work that way. Let's use this. 15 is what we're looking for, so let's do it as cos 60 minus 45. So this will work. Okay, so cos 60 minus 45 will give us cos 60 cos 45 plus, for cosine, plus will be minus, minus will be plus. So plus sine 60 cos 45. I mean sine 45, I'm sorry. So this becomes cos 60 is 1 over 2 multiplied by cos 45 is root 2 over 2 plus sine 60 is root 3 over 2. Sine 45 is still root 2 over 2. So root 2 over 2 is common. Root 2 over 2 is common between 1 over 2 and plus root 3 over 2. So let's work this out. We have root 3. That means 2. So 1 plus root 3 rather times root 2 over 2. Okay, so this becomes root 2 multiplies it. We have root 2 plus root 6 over 4. So this is the answer for cos 15. So sin 30 is 1 over 2. So 1 over 2 times sin 30, which is 1 over 2, multiplied by root 2 plus root 6 over 4. So our answer becomes root 2 plus root 6 over 2 times 2 times that, that's 16. And that is the final answer for this one. Exactly. So that is how to evaluate it. But you can find an identity for this also, because it can work for other examples. Okay. So it will just follow the same principle. Cos theta over 2, cos theta over 2, cos theta over 2, cos theta over 2, minus, because plus is here, sine theta over 2, sine theta over 2. So looking at this, cos theta over 2, cos theta over 2 is cos squared theta over 2 minus sine squared theta over 2. Then you can begin to do your substitution again, since sine squared theta plus cos squared theta is equal to 1. You bring in a value for an identity, you substitute it for sine squared theta, and you get another new identity. So that's how to go about it. Do well to subscribe to the channel. God bless you.